page is what we did on Friday. So let's see, today is November 6th. All right, let's take a look. So it says decide whether this function is a polynomial. So if you remember back to Friday, or if you don't, I have the notes out here. There were basically 4 disqualifiers in terms of what was or was not a function. And so the things that disqualified, not a function, a polynomial. The things that disqualified a function from being a polynomial were things like dividing by the variable. So if you see a variable as a denominator here, it can't be a polynomial. I don't see a variable being divided by here, so that's fine. If you see a variable raised to a negative number, so a negative exponent with a variable, that doesn't work either. I don't see that here, so we're good so far. A variable raised to an exponent, or a variable as an exponent, I should say. I don't see a variable as an exponent here. And then the last one, a root of the variable. And this is where you have to really pay close attention, because this here is not the root of a variable. That's the square root of 7. X to the 4th power is not underneath the root. It is not under the radical symbol. So if it was drawn further over the top of the x to the 4th, then it would be under the square root, which would not make it a polynomial. But because x to the 4th power is not under the square root, this is a polynomial. So we're going to say yes. And then we're going to say g of x. We're going to write this in standard form. So we have to go with the highest exponent first. So that would be the square root of 7 times x to the power of 4 plus 0.675x minus 21. State its degree. The degree is the highest single exponent, which is 4. So it's a degree of 4. The type is what we saw on the first page of our notes from last week. So if the degree is 4, does anybody remember the name? Quartic, yeah. That is a quartic. And then the lead coefficient is just the number in front of the highest variable with the exponent. So square root of 7. There we go. All right. That's it for that one. Number 2. Evaluate f of x. Here's our function when x is equal to -2. So everywhere you see x, plug in -2. So here we go. This will be f of -2 is equal to 4 times -2 to the power of 5 minus 3 times -2 to the power of 4 plus -2 squared minus 5. And that, if you have a calculator, can be typed in just directly into the calculator, which is perfectly fine to do. Let's see. We've got 2, 4, 8, 16, 32. So this is -32 times 4. That'd be what, 128? -128? Yeah, that's -128. 2 to the 4th power is 16. 16 times -3 would be -48. 2 squared would be +4, and then -5 at the end. You don't have to write it out like this if you don't want to. You can just type the whole thing in, which is totally fine. -48 plus 4 minus 5. So what do we get? -177. So f of -2 is equal to -177. That's our answer there. Cool. They just plug in the value of x. So we're just going through the stuff that we talked about on Friday. Describe the end behavior. All right, so is this an odd or an even? Even, okay. Is the lead coefficient positive or negative? Negative. So that means we're looking at even with a negative lead coefficient. That would be down on left and down on right. That's the answer right there. So you just go to the chart that we made on that second to last page on Friday. Even highest exponent, lead coefficient of a negative number. That gave us a down on left, down on right situation. All right, the next one is a graph. Pop this up real quick. So this will be negative x to the power of 3 plus 5x squared minus 2x minus 5. All right. So first of all, the minus 5 at the end, that's our y-intercept. So the y-intercept is negative 5 for sure, which is here. And then the graph looks like that. So in terms of what we did on Friday, I just want to review this process with everybody real quick. So even if you have a calculator or not in front of you, the easiest way to get the points that you need are to use the calculation menu from the graph. So if you click on second and then trace, that'll take you to the calculation menu. And what we want to look for first, let's get our zeros. The zeros are the x-intercepts. And so if you go to 0, it's going to ask you for a left bound. So we want to go to the left of this x-intercept here, hit enter, and it'll say right bound. So go underneath to the right side and then enter. And then it's going to have guess, and you say, yeah, that's fine. And then the 0 is at negative 0.77. So that's like 3/4 of the way to negative 1. By the way, this is negative 1. So each line here is basically a quarter. So we're just going just past the negative 0.75, like right there. The scales for x and y are very different on this. Then the next 0. So you go back to your second calculate menu, go to the next 0, keep going here. Left bound will be underneath this one. Right bound will be above it. Enter, enter. That's like exactly 1.5, pretty much exactly 1.5. So our next x-intercept, just put that right on the 1.5 right there. That's fine. Our next x-intercept, so second calc, go to 0. Left bound will be above this last one. So there's 3 x-intercepts. The right bound is underneath. Enter, enter. 4.25. All right. So 4.25 is like right here. So far we have 4 points. We have our 3 x-intercepts. We have our y-intercept. Now we need to get our local minimums and local maximums, the turning points. And the way we do that, you go back to the calculation menu. Let's get our minimum first. So just go to where it says minimum. Hit enter. I see a minimum down here. I'm going to go to the left of that minimum for the left bound. Hit enter. Go to the right of the minimum for the right bound. Hit enter. It'll guess. And then you say, yeah, that's fine. So x is at 0.21. Y is at negative 5.2. So almost to a quarter. And then down just below, about right there. Just below the y-intercept. So you got a point right about there. That's a local minimum. And then we'll get our local maximum. So go back to calc. This time we're going to scroll down to maximum. So we want a local maximum this time. The left bound will be just to the left of this local maximum. The right bound will be to the right of the local maximum. We'll guess, and it says 3.11, 7.06. So 3.11, that's about halfway in between 3 and 3.25. And when 7.06, so let's see, 1, 2, 3, 4, 5, 6, 7.06, that's about right there. So we got 6 points on here. We have our local max, our local min, we have our 3 x-intercepts, and we have our y-intercept. And then we're just going to go ahead and just kind of sketch it the way we see it. It's going to be a little bit stretched out this way just because we're going by 0.25s along our x-axis, which is not necessarily a problem. If we wanted to match it, we could. We could say positive 10, negative 10, then the x minimum would be, let's see, negative 4, x max is positive 4, the scale is 0.25. So then we can go back and make it look a bit more like what we have here. It'll widen it out a little bit, kind of like that. Make it look roughly about what we have on our paper. So here we go. We'll drop it down from the top and let's see. About like that. Now we're going to bring it down. It turns here, goes back up. We got our local maximum up that way, about like that. And it'll drop down about like that. So that's roughly about what our graph looks like. Now, this is definitely an odd function. We know that. And we have a lead coefficient of a negative, and that was in the actual function itself. But if we saw the function, we would have been able to say that much information anyway. All right. So let's keep going here. It says to sketch Sketch a graph that increases when x is between -3 and +5 and decreases elsewhere. Also, the constant term of the polynomial is 2. The constant term is the number at the end. That's your y-intercept. So if we want to, no, you can go. I'm just going to put some numbers. It actually looks like maybe there were some numbers on here before. Let's see. 1, 2. We'll just do this kind of thing. Just evenly space some points here. Or as best as we can, evenly space some points. The reason why I'm doing this is just because we actually have numbers in here that we can use. So the constant polynomial is 2, which means we have a y-intercept of 2. That's what that means. That's the y-intercept. So constant polynomial, that's the y-intercept. All right. Let's see. This graph is increasing between -3 and +5. All right. So, and then decreasing elsewhere. So that means we have a turning point. We have turning points at -3 and +5. So at -3, and then 1, 2, 3, 4, 5, +5. So it's increasing between these two. So that is going to be down here, and then it'll go up, and then so +5, 1, 2, 3, 4, 5. So that'll be up here. So I think it's going to look something about, I mean, it's not great, obviously, but something like this. Pretty sloppy, but that's about all the information we have, though. So it's a lot less detailed than the very last one that we just looked at from the last notes. So that's your recap based on the stuff we did on Friday. So quick, messy sketch there before we continue to the lesson today, which, honestly, I think a lot of the stuff we're doing today, you've actually done before back in Algebra 1. So that's why I'm giving a lot of time to the warm-up today, because the stuff that we're doing here is going to be very much reviewed. Now, the wording here is a little bit weird. When it talks about the formats, the vertical and horizontal format, that just means how you actually write the problem. So for example, adding vertically means you're going to write one above the other, or subtracting vertically means you're going to write one above the other. Horizontally means you're writing them next to each other. That's all that means. So for A, if we are adding these vertically, that would be, let's see, 3x to the third power plus 2x squared minus x minus 7. And we're adding, so it'd be plus underneath it. X to the third power minus 10x squared. I don't see anything with regular x here. So I'm just going to leave this blank because there's nothing with regular x. And then plus 8 at the end. Everybody okay with that? There was no regular single value of x on this function here, on this second polynomial. So we just leave that spot blank. And then all we do is combine like terms. That's it. There's nothing special going on here. So 3 plus 1 is 4. So that'd be 4x to the power of 3. Remember, when you combine like terms, variables and exponents stay the same, and you just add or subtract the coefficients. 2 plus -10 is -8. So that'll be -8x squared. -1 plus 0 is -1. So minus x. -7 plus 8 is +1. So plus 1. So that's the answer. It's literally combining like terms. That's all you have to do. Now, the other format is horizontal. And the horizontal format is also something that you've seen before, and it's where you write each polynomial in parentheses and then combine like terms. So the process isn't any different. How it looks is a little bit different. So this first one would be 9y to the power of 3 plus 3y squared minus 2y plus 1 plus, because we're adding these polynomials together, negative 5y squared plus y minus 4. And then you just pick out your like terms and you combine them. Nothing more than that. So the 9y to the third is the only power of 3. So that's 9y to the third. Squared, we have 3 plus negative 5. That's negative 2. So minus 2y squared. Negative 2y plus y. Negative 2 plus 1 is negative 1. So that'll be minus 1y or just minus y. And then 1 plus negative 4 would be negative 3. That's it. You've all done this before. Look familiar? Hopefully. Yeah. All right, subtracting. Let's keep going. I think the lesson itself today should be pretty quick. Subtracting polynomials horizontally and vertically. So it's the same thing we just did, but we're subtracting. So A, vertical format, 2x to the power of 3, 2x cubed plus 6x squared minus x plus 1. Subtract. I'm going to put this other one in parentheses. So we're subtracting 8x cubed minus 3x squared minus 2x plus 9. Now, what is different about subtracting polynomials versus adding them? What do you have to do when you subtract that you don't have to do when you add? We did this with complex numbers in the last unit as well, when we were adding and subtracting complex numbers. Yeah, distribute the negative. Exactly. So I'm just going to write that off to the side. Distribute. Distribute the negative. If you are subtracting polynomials, you have to distribute the negative to the second polynomial. But that's really the only difference. So here it would be 2x cubed minus 8x cubed. 2 minus 8 is negative 6, so that's negative 6x cubed. 6 minus negative 3 would be 6 plus 3. That's 9x squared. Negative 1 minus negative 2. That's negative 1 plus 2, which is positive 1. So that's plus x. And then 1 minus 9 is negative 8. So there we go. Oh, you know what? I wrote that backwards. I'm sorry. That should have been the other way around. Not bad. It says subtract this one from that one. Everybody see that? So yeah, that's my fault. So we need to rewrite that. Sorry. Let's see. 8x to the third. It's not going to change the answer too much, but it definitely will change the answer. If it was addition, it wouldn't matter. But because it's subtraction, it matters. So let's see. 2x cubed plus 6x squared minus x plus 1. I was just working too quickly. So the word from means that this one is being taken away from that one. So in the order of subtraction, this one has to show up first, and then that one gets subtracted from it. Hi, Daniel. Bye, Daniel. All right. 8 minus 2 is 6. So that's positive 6x to the third power. Everything's going to be opposite, by the way. Negative 3 minus 6 is negative 9. So that's minus 9x squared. Negative 2 plus 1 is negative 1. So minus x. And then 9 minus 1 is 8. So there we go. Everything turns into its opposite. So that is A. All right. For B, make sure I read this one more carefully. Subtract this one from this one. So the binomial comes first, and we're subtracting the trinomial from it. So that would be 2z squared plus 3z minus 3z squared plus z minus 4. And you can actually distribute it if you want to, or you just know that that has to be distributed, and then you can do the math that way. So for example, 2 minus 3 on the squareds would be negative 1. So negative 1z squared or minus z squared. 3 minus 1 is 2. 3 minus 1 is 2, so plus 2z. And then for the constant term, there is no constant in this first binomial, so we're going to take the opposite of negative 4, which is positive 4, so plus 4. So far, this is all Algebra 1 review. In fact, I think everything today is pretty much Algebra 1 review. Even if we go to the next page. Yeah, there's really not really anything new in this lesson, which is great. It means we can move through it very quickly. Because I think we're only going to have about 5 more minutes of notes, and then you're going to have a good 15 minutes to work today. So here we go. Multiplying. All right. Now, in a vertical format, this might not be a way that you've done polynomial multiplication before in a vertical format. You've probably only done the horizontal way. So this might be a little bit new. However, you have multiplied in a horizontal format before. For example, if you were to take 456 and multiply it by 12, like that, what would you do first? What's the process for multiplying like this? What do we do first? 6 times 2? Okay, that's 12. And then what? Carry the 1. 5 times 2 is 10, plus 1 is 11, carry the 1. 2 times 4 is 8, plus 1 is 9, right? Remember this process from like grade school? What comes next? Yeah, so placeholder 0. Why do we do that? This is the tens place that we're multiplying by. Nothing goes in the ones place when you're multiplying everything by 10. Yeah. So basically what we're doing is we're multiplying this entire thing, like everything gets multiplied by 10 now. So 1 times 6 is 6, 1 times 5 is 5, 1 times 4 is 4, and then we add, right? So 2, 7, 4, carry the 1, 5. 5472. Cool. So basically what you're doing, did you know, by the way, that this is essentially FOIL? When you do this, did you know that? This is basically FOIL. Because you're basically taking 456, you're multiplying it by 10, and you're multiplying it by 2, and then you're adding those results together. That's essentially FOIL. So anyway, let's go into here. We're multiplying these two together. So we got the opposite of x squared plus 2x plus 4 times x minus 3. All right. And we're going to do this just like we did a minute ago. So we start by multiplying from the constant row, and then we multiply from the linear row, which is kind of like multiplying from the ones place and then multiplying from the tens place. So negative 4 times 3 is what? Negative 12. Here's the weird thing. We don't carry. We're not using the carrying method here. It's the same type of process, but it's not the same process because we're multiplying the constant by every term, and then we're multiplying the linear by every term. So negative 3 times 4 is negative 12. Negative 3 times 2x is what? Okay, so negative 6x. And then negative 3 times negative x squared is what? Positive 3x squared. Yeah. All right. Now we're going to go ahead and say, all right, we were done multiplying the constant term. So there's no other constant here. So that's like our placeholder. It's not like a ones, tens, hundreds thing, but it's the similar idea between the terms because we've already multiplied by the constant term. Now we're multiplying by the linear term. What's x times 4? Positive 4x. Okay. What's 2x times x? Anybody remember the exponent rules? 2x squared. Yeah. Anytime you multiply exponents together, you add the number of exponents when you multiply them. So x and x, they each have an exponent of 1. Add the exponents, you get 2. So that would be plus 2x squared here. And then what is x times negative x squared? Negative x cubed, exactly. And when we end up writing it like this, it ends up putting everything that is a like term in the same place in the problem, and then we can just add it together. So let's just add everything through here. So negative x to the third power, 3 plus 2 is 5x squared. Negative 6 and 4 is minus 2x, and negative 12 and 0 be minus 12. Oops, there we go. Have to cross it out a little bit. Cool. Now, what you're probably used to seeing is the horizontal format. which isn't really any different than this. It just is a different way of showing it. So the horizontal format, B, we're going to take our y plus 5, and we're going to multiply that by 3y squared minus 2y plus 2. And we're just going to use the distributive property twice. Take y, multiply it by all three of those. Take 5, multiply it by all three of those, and then combine like terms. This is the way that you did it in Algebra 1. We didn't look at the horizontal method. By the way, the vertical method. The vertical method is going to be useful when we start dividing polynomials. So that's why we're kind of setting this up now. So let's go ahead and distribute. Y times 3y squared would be 3y cubed. Y times negative 2y would be negative 2y squared, and y times 2 would be plus 2y. Then take the 5, multiply it by everything as well. 5 times 3y squared is 15y squared, positive. 5 times negative 2y would be minus 10y. And 5 times 2 is 10. And we'll just match up our like terms and put them together. There's only one cubed term here, so that's 3y cubed. We've got a negative 2y squared and a positive 15y squared, so that'll be plus 13y squared. 2y minus 10y is negative 8y, and then a plus 10 at the end. Does this process feel familiar? Binomial times trinomial, distribute all three, add like terms. Any questions before we move on? I know I'm moving quick, but hoping that you either remember it or now that you're seeing it, you're like, okay, I remember doing that. Any questions? Okay. Flip it over. By the way, we're only doing this next problem. All this stuff down here, don't worry about that. So we only have one more problem to do. So it says multiply all three of them in a horizontal format. This is probably something you haven't done before. Although it's not really going to change how we really do this at all. Basically, you're multiplying three numbers together. You're multiplying three binomials together. So this is going to be x minus 1 times x plus 4 times x plus 5. And you're multiplying it in a horizontal format. So there it is. So what we're going to do is we're going to FOIL out two of the three, combine like terms, get a trinomial, and then multiply the remaining binomial by the trinomial that we just formed. If I was going to do this one on my own, I would probably start with the x plus 4 times the x plus 5 in terms of FOILing. That's how I begin this process. So this would be x minus 1 times first is x squared, outer plus 5x, inner plus 4x, last plus 20. So we're just FOILing out x plus 4 times x plus 5. We'll combine our like terms here to get 9x. So it'll be x minus 1 times x squared plus 9x plus 20. Now this problem looks exactly like the one we just did. So finish this one up. Multiply the binomial times the trinomial, combine like terms, and that's it for our notes today. All right, so there's the answer if you want to double check it. X cubed plus 8x squared plus 11x minus 20. All good? Cool. All right.